If your websites conduct transactions or collect sensitive data, you have a material risk on your hands that could cost millions. The client-side security gap is being exploited daily with attacks like digital skimming, credential harvesting, and form jacking. 98% of sites use first and third-party JavaScript to power and enhance the user experience, opening up the client side to the adversary. Unlike most things in security, there is an easy fix. Start by understanding your risk. Let Source Defense give you a site-wide risk report this week. Visit securityweekly.com/source defense. Welcome back, everyone, to Paul's Security Weekly. I'd like to welcome our new sponsor, Perception Point. The need to communicate and collaborate on a global level has created a proliferation of cloud-based tools for businesses. But with new channels come new gaps for hackers and many new security blind spots. You need full threat visibility across channels with a solution that works at the speed your company does. Perception Point's multi-layered platform provides the most robust threat prevention on the market. Perception Point Advanced Collaboration Security designs for the modern enterprise. Visit securityweekly.com/Perception Point for more information. Join us on March 10th for our next Security Weekly Unlocked webcast, an intro to KQL queries with Darwin Salazar and Tyler Robinson. Make sure you visit securityweekly.com/webcast. We only ask for your name and email address, and we'll only use your email to send you stuff related to the webinars that you attend. Alrighty, we've added some people to the news discussion. First on the lines remotely, no stranger to the show, of course, Mr. Jwt Thayer is back after a little hiatus. It's good to have you back, Jwt.
Hello, Paul. It's good to be here. Thanks for having me back. It's good to see everybody as usual.
And here in studio with us is Dave Marble. He's the CEO over at OSHEAN. Dave, you a few years ago came on the show, and then you're back.
I'm back.
Remind everyone, I want to hear from you, what is OSHEAN?
So OSHEAN is the state's research and education network. We run about 600 miles of fiber around the state, and actually in the Southeast Mass region as well. We, interestingly enough, just upgraded 235 nodes of packet optical gear that now have every node in the network is capable of 100 gigabit transport. We just did a massive upgrade to the network, which makes it the best of its kind in the business. And so we help all the other nonprofits in the region. So the meds and eds, all the universities, K-12s, hospitals, libraries, a lot of the government, state government, local governments connect to a very, like I said, sophisticated packet optical network.
And that's for both internet and internet 2 for EDUs.
We do peering with internet 2, and so what happens is, depending on whether you're at St. Rosa Lima's school or you're at Brown University, you may need to, transport your email, or you may need to transport, a research.
Terabytes of research data.
And everything in between.
And an internet 2, I imagine now it's like you're on the same network.
We are paired. We're paired with internet 2. They just upgraded their backbone optical to 400 gig.
Wow.
Man, that's internet 2. I haven't heard that in forever.
Yeah.
Internet 2 is, and it's global now. And it's the sophistication of these networks. In fact, I just got off a national conference with Internet 2, and we were talking about quantum networking. We're getting into,
well, that was always the exciting part about being involved with OSHEAN. I worked there at OSHEAN, and I worked for EDUs, was just the constant innovation, even just on the network side. Like, if you just take that by itself, the innovation is just constantly happening.
Well, all the companies, whether they be a school or a business, are going through digital transformation, as we all know, right?
Yep.
And so, this is about securing it. Once you put it in there, now you're going to secure it.
You can hack it faster now. Yeah, Jwt comes from the EDU space as well.
Yeah, I was going to say I spent many years not only working local university in North Carolina, but I consulted a lot and worked with MCNC across North Carolina. So
I talked to Mark Johnson today.
Oh, I remember that name.
Literally talked to Mark. Literally. About a couple hours ago.
And to think, Paul, OSHAN is the reason that we started this podcast.
That's right.
16 years ago.
Larry and I met through OSHAN in events at OSHAN, which we're having one next week.
Shore Patrol.
Shore Patrol.
We still have Shore Patrol.
So
Is OSHEAN still designed for delivering large files rather than smaller content? And I think you know my friends over at ESNet.
Very much. They're on Rev 6 of that unbelievable. In fact, a lot of the techniques for large file transfer really comes out of ESNet and the innovations that they've done.
What is ESNet?
Energy Sciences Network. So that's your DOE.
Yeah.
And it's second to none in the world. And what they've done is, much to your question about large files and large flows, is they've developed special techniques for large files. So if you want to get 40 gigabits across, to the University of Chicago and run a petabyte file across, well, how do you don't do that even with just a straight connection. So they've ESNet and a bunch of the R&E community have invented data transfer nodes for those really large file transfer stuff. And that hits security too, because how do you get what they call elephant flows through a firewall, right?
Right.
And all that kind of stuff. So we're dealing with a lot of that stuff. And so we do that, but we don't, like I said, we don't ignore the emails and the standard files and the standard commodity internet stuff that the smaller guys need to use and that kind of stuff.
Was security baked into a lot of that consideration? I mean, obviously working with DOE and some of the other places that you're working, that seems like a super hard problem to solve with security integrated into the performance of what you're trying to do.
It wasn't initially, right? So as things developed, what ended up happening, and this is why you ended up with shadow IT at some of the universities, because the researchers would get an NSF grant and then they just route around IT because they didn't want to go through the firewall. But that had to stop because of compliance, and compliance started to hit the universities themselves. So now you're sitting there saying, well, so what ended up happening was, even a lot of the firewall vendors started to build support for things like elephant flows in concert with the others. So they actually call them mice flows and elephant flows now, and that kind of thing to deal with that problem. And so it evolved over time.
Have a segment on this. I'm just saying, this sounds like a great segment, and there's a lot more I want to ask, but I know Paul has news.
We have news and stuff.
That's kind of funny, though. I want to make one comment. Right when I left the university space, it was about 2011, 2012. That was emerging, right? There was this entire discussion. It was a science DMZ proposal at the time, and it was exactly addressed at that issue of how do we get really high performance and at that point in time evade the security controls because they were perceived as the problem. And I'm sure that's evolved now.
And now we're building the national research platform. Which is essentially an amalgamation of the technologies from science DMZs that started back when you're talking. Right? So,
that's kind of it's funny how things come full circle. Anyway, let's do some news.
Just really quick, SecureCon 22 is happening next week on the
15th at Bryant University.
That's right, my alma mater. Get to go back.
We're back in person, which is extraordinary, and I didn't know whether people would come. Right? So we had to put a stake in the ground and say, we're just going to come and see how many people come. And we're already up to a couple hundred people already registered. Good. It's going to be a big event. It's going to be wonderful.
Yeah, there's multiple keynotes, leading a discussion panel on XDR, what it means, how do you use it, that kind of thing, and some great keynotes and stuff. So I think there's still time to register, right? So if you're local, if you're local and you want to attend next Tuesday, it's from 9 a.m. to 3.
OSHEAN.org, ocean.org, and you'll see SecureCon there, and registration's still open. But
is it free to register?
It's free.
Totally free event. Look at that.
If it's free, it's for me.
Yeah, and it's a really wide range of topics. It's it's got national perspective. There's a really cool guy you'll meet, Chris Painter.
Yes.
Who's doing and he'll give you a federal perspective and that kind of thing. And then there's the local people like our local CISA rep, Mike Tatro, and our CISO from the state, Brian Tardiff, and people like that will all be there. And then people from the vendor community, and Todd Knapp and Jason Albuquerque, Jason, who you guys know really well.
Here in Security Weekly.
Yeah, exactly. And they'll all be there doing their part. So it's going to be great.
It's going to be a lot of fun. I'm looking forward to it. I hope folks can register. On to the security news for this week. where do we want to start? Lots of good stuff happening. Where are all the stories?
Always lots of good stuff.
I scrolled too far. Talk about the Linux one. Just lead off with that. I mean, another Linux one. This is like the last couple of years have just been like hit after hit from the Linux kernel. This one's dirty pipes, taking advantage of the way Linux rather uses pipes. Linux kernel 5.8 or later, up until the versions where they fixed it. The way it was found was kind of, someone was like doing some troubleshooting and uncovered a vulnerability. And when you read this or try to read it and follow along and your brain hurts, don't feel bad, because this person was troubleshooting for like months before they could, one, figure out what the problem was, and then two, figure out that like this actually was a vulnerability, and then develop an exploit. And so I think sometimes the perception is that, oh, someone just stumbles across this and writes an exploit, and you know, it's a couple hours or a day or whatever. Like, this is months of work, and you're consuming that months of analysis and work. So I link to the news article. Dan Gooden, as always, did a fantastic job. The best job, A, for the day, for Dan Gooden on writing this up. I also link directly to the dirtypipe.cm4all.com website, which, if you want to go read all of the gory details, in addition to a neat little exploit that I found. So
I'm compiling that right now.
Yes.
Kind of around that, the autopilot one for GKE was also super interesting from Unit 42.
Wait, I was still on Linux. Now you're hurting my brain, Tyler.
So GKE, Google's Kubernetes engine, runs on Linux. It's the Eddie handoff one.
You know what? Our listeners, you got a lot of reading ahead. So we kind of just summarized the Linux one at a very high level. There's a lot of details in there.
Make 2 hours.
And like make sure you update your kernels, because it's similar to Dirty Cow, but more reliable and easier to exploit.
Is that why they named it? Mm-hmm.
That's why they named it. Yeah, that's why they named it that way. It was basically like an unassigned variable was one of the things that led them to some other, I don't remember what it was, other condition, right? And that's usually how these Linux kernel things are playing out. Usually it's like multiple vulnerabilities, if you will, although I use that term kind of loosely, right? Multiple conditions that exist that allow for ultimately exploitation. So that was the Linux one, and a lot of really cool stuff to read there. There's also the container escape one, which Tyler was mentioning. GKE is Google's Kubernetes engine. Google Kubernetes engine. And they had this feature called autopilot, and like as soon as you see autopilot, you're like, oh,
what could possibly go wrong?
But I think it goes back to John Strand and researchers when they were talking about some of the vulnerabilities that were present when like AWS did auto scaling. So like you had this environment, and then if it auto scaled, it would create like more resources for that environment. But when it created those new resources, those had default configurations and some vulnerabilities in them. This was it would, when I read autopilot, I'm like, oh, it must be like a similar kind of thing. When stuff is happening automatically in the cloud, maybe there's some security configurations that kind of get left over. But this one went really deep. If you don't know Kubernetes, like I am not a Kubernetes expert, you're going to want to like fill in that background first and then go start reading this. I've also not done GCP or Google Cloud stuff. So if you're coming in this article like I was without really being familiar with Google Cloud and not really being familiar with Kubernetes, you got some studying to do before you can get to this article and go, I like the container stuff I can understand, and like the basic Kubernetes stuff I get, with pods and all that stuff. But essentially it lets you break out from that whole system, which could be bad.
You can escape the pod, get to a node, which is essentially like the controlling unit of the pod, and then from there you can actually escalate your privileges to administrator, and then you can end up getting admin access and become shadow IT, which lends itself to some interesting stuff like deploying crypto miners, putting webhooks within inside of applications, taking secret API keys, like those kinds of things that when you think about where GKE is deployed and some of the underlying technologies that use GKE, you're talking about very high load, high frequency distributed clusters that have a really big amount of compute power. And so you already, like, if you just think about, hey, it's just GKE, it's just like my Azure account or my AWS burner account, like those don't seem that bad. But then you start thinking about things that run on top of this to provide you services or SaaS applications that run inside of a cluster or a Docker container or Kubernetes pod. Those things are pretty valuable, and they have to be secured, and we're relying on that security.
It's big companies and big applications that are using Kubernetes, and especially in Google's cloud, because Google created Kubernetes, I think, to solve some of their own problems, which Google has huge scale problems, and that was one of their solutions. I think people often adopt the technology going, oh, I want to use Kubernetes, when they really don't have a use case for that. Like, they could probably just get by with regular containers. They probably didn't need to take that step. But there are, like Tyler, you're saying, there's a lot of big apps that do use Kubernetes. And
well, it's also it's penetrated research in the universities, because
I can see that.
They're trying to make their applications mobile, right? So that they and so Kubernetes is the choice of the National Research Platform for designing the next gen, mobile application, if you will, for research. And that's just, I don't want to call it rogue, but that's just individual institutions with grabbing Kubernetes developers and developing straight in the university research application, which is not what you would call traditional enterprise apps or things like that. And so who knows what.
I mean, you think about what kind of things need to run on clusters and swarms and pods for these things. You're talking about gov clouds. You're talking about very large-scale hypervisor abstractions of hypervisor layers and the applications that are being provided on top of that. Like, we're probably 4 layers abstracted from some of this, but that means that if you're able to break out of that pod, container, whatever you're in, escalate your privileges, and then get to the underlying OS, like, you're talking about a very, very large amount of compute power that can do a lot of things, like mine a lot of crypto. Like, that sounds like a great use case, and probably a waste one, honestly. But
you're exactly right, and if you consider that not even at the university level, even the Yales of the world are realizing that the 4 walls of Yale's, even at a research level, they can't handle it. So now, there's the supercomputer centers, like the one closest to here is the Mass Green High Performance Computing Center in Holyoke, Massachusetts, and that place is ridiculous, right? And so that's where they're now getting together for these massive GPU clusters and that kind of stuff, and the massive storage environments like petabyte level open storage networks that are funded by NSF, right? And so now all the universities want to make their applications mobile so that they can run, and move back and forth between, their institutions and Mass Green high performance.
Yeah, I mean, that's kind of one of the bad things about you limit this down to, say, like crypto mining, right? Like, all right, okay, so some crypto mining happens, some people made some money. That's a pretty small scale and pretty short-sighted version of what this could be used for if, say, like a nation state got a hold of this. They put something on that cluster to chew through something like an RSA key that may be a master key for something like a certificate authority or root authority. You're talking about getting to that point where you're almost at quantum level compute power to do distributed loads and chew on things that are very important, that if they were cracked, have bigger implications rather than just crypto mining. When I see crypto mining, okay, yeah, that's one thing. You can make a lot of money from this, but that's a pretty small feature that could be gained from gaining access to systems that have these kind of compute power.
It pales in comparison to the intellectual property that's going on, in those applications for research in the United States.
Pharmaceutical, genomic sequences.
Right. Larry, you had your story number 4.
Okay, yeah.
It's about a university campus.
You're going to make me scroll up here.
Yeah. I saw the headline. Admittedly, I did not read the article. It was how a simple security bug became a university campus master key.
I read through this and barely, I'm like, I got to go back and read this later. And of course you didn't. I never did. Specifically, one of the things, though, he could. So there's a student who couldn't get his mobile app for his student ID to work, so he found a workaround looking like he wrote his own stuff to the API effectively, the web-based API for a software application called Seaboard. And Paul, you and I know have heard Seaboard before.
I've heard Seaboard before. I see that in the article.
This is like the evil made or the master made key attack, except for university. So like, they should have called this like master frat or something.
Yeah. So turns out the API took your student credentials to interact with it, but the API wasn't actually checking to see if the credentials are valid.
Yeah, there's logic errors in APIs. Yep.
Yeah, only check the unique ID, and if it was worked, yeah.
Oh, and Seaboard is the thing that controls the doors.
Yeah. So not just doors, though. You're talking about like commissary backend, any of the access control for the university. There's a bunch of stuff that this API was communicating with that ties into the school. You think about the school; it is a master corporation that has accounts that users interact with and gain privileges to resources and or have debt against. So the key itself was kind of a small piece to this, I think.
Yeah, and they noted the scary part was because it was API level, it didn't just affect single university; it was potentially every university.
Right.
Oh, I didn't see that.
Oops.
Right. And apparently, they're being real cagey about the fix too. Seaboard isn't talking to customers.
Access control companies are always like that. That you talk about, like, unless you're talking about one of the big ones, even like Siemens or any of the other ones, like most of them, if you break even the physical door locks, you break the mechanism in which they rely on to secure things because they're a security company, essentially, they get super cagey and they're very hesitant to be transparent about what happens just because of the amount of work it takes to fix it and how their technology doesn't usually have a good fix. It's usually a re-architect, whether it's physical or...
In this case, though, they could likely fix the API. Hopefully they have.
They allegedly have already fixed it.
Oh, good.
I mean, that seems simple enough to do just to validate the credentials you were given.
Right.
Right.
But who knows? Who knows?
There was something else API related now that you say that.
One pseudo...
ServiceNow.
Oh, ServiceNow. I didn't see this one.
Most ServiceNow instances are misconfigured and exposed. Now, I couldn't find the details. However, after reading like the description, I'm like, this sounds like an API. So they're researching it. External interfaces were exposed to the public that could be utilized by a malicious actor to extract data from records. 70% of the tested ServiceNow instances were vulnerable, which could allow an unauthenticated user to extract data. Further investigation of these findings highlight the root cause for data exposure are combinations of misconfigured ACLs and over-provisioning of permissions to guest users. See, that to me doesn't sound like it's a SQL injection. That sounds to me like you can gain access to the API, and the API will spit back some data, even if you're just a guest user, and get access to stuff.
They're being cagey about this because this has been brought up multiple times. Like Salesforce had a bunch of issues until they finally got their head out of there, hired some security guys, got a good bug bounty program, and took a forward approach to this rather than some of the ways other companies do this. This one is, you think about the things that integrate with ServiceNow, you think about the open APIs in order to get data and receive data both ways, and we abuse this all the time, especially for ServiceNow at large companies, because they have HR integration, they've got CRM integration, they've got accounting and invoicing integration, often not the same platform. All those things tie together, and that SaaS application is not one application, it is multiple API endpoints that provide different data points. And so they can't really give up too much because they can't fix this, because a lot of the integration relies on how this works. And so you're faced with RBAC, your role-based access control mitigations to do this right. And then even then, you're talking about API keys get passed, and maybe it's securely, maybe it's not, maybe the other end of the platform can handle those API keys or dealing with those, or they can't. And so you run into a bunch of problems with SaaS applications like this.
Well, I feel like I got to run out of the studio and call my CTO.
Because you're not wrong.
Because we use ServiceNow to great extent, and we're actually in the process of doing a CRM integration into ServiceNow. But if you look at the extensive use of the ServiceNow database and the API programs that we're doing, all the way to levels of automation for like we do a DDoS mitigation umbrella across all our members, right?
Mm-hmm.
Well, that uses integration into a system called Kentic, which learns the attack vectors, right? And that's your analytics front end. So there's integration there, and then there's a back end scrubbing center, you know, at Akamai, and we build automation off the recognition. So the automation goes and turns everything. So that's all through APIs and ServiceNow integration. And,
right.
And then you got the API for the data lakes and then the connection to the data connectors.
Yeah.
That are probably another application.
But that's what
I'm
it sounds like
screwed.
to me. You know, like ServiceNow is a massive suite of applications, all API driven. Anytime you have that, they're going to take certain liberties in ACLs, in permissions to go, this service needs to talk to that service. It's over an API. Oops, I forgot to validate that you should have these credentials to access that data that comes back from that API. That I can see.
Not even just that, like the ability, like for you to push data there that may be serialized or deserialized on the other end, and validating what kind of data that is. Like it does some amazing things on the back end side of that API that you have to be able to accept as a SaaS provider.
And if you think about it from my perspective, right, because I'm not nearly as technical as all of you, right, and I think about it and I sit here and I say, well, yeah, I'm covered with my service. I've got multi-factor authentication over the top of this whole thing. I've got all all of these. You know, I do scan. I do all my vulnerability scans. I do all that, right? And then I turn around. It's like, well, who's protecting the APIs inside of?
Yeah,
right.
Completely different animal.
It's a different aspect
different
of security that I think needs more focus today. You know, Dave, to your point, is the configuration of your SaaS-based services. Who's your expert that knows it well enough to go, I need to apply this configuration in order to be secure in my specific instance in configuration of ServiceNow, right? Not someone else's. Ours is different, right? I mean, these applications are not written so that, you know, just anyone can use them and it's vanilla off the shelf. These are all what was the one you mentioned? Not ServiceNow, the CRM company.
Salesforce,
CRM. Right?
Yeah.
Like Salesforce is basically allowing you to develop on their platform, essentially, to customize the application. And that level of customizability can easily lead to a lot of different security loopholes.
Well, it gets even worse than that. One of the cool things that ServiceNow offers is they allow you to put a middle tier, an integration server on your network, so you're talking to it behind your firewall.
Right.
The problem is it kind of sucks. So you wind up taking it out and talking directly to ServiceNow, and there's some things that won't even work with it. So the nice, clean security model goes out the window.
Right.
But you can, if you've got some layer 7 protections between your legacy systems, you can watch for abuses to the API. But
well, and not to say not to sound, just throwing up my hands and giving up, but we put in this architecture, which uses again this Kentic analytics system and all that stuff to replace SolarWinds that was doing that in the first place.
Oh wow!
What were you thinking?
Right?
I know what he was thinking.
You want to use SolarWinds.
This whole discussion kind of reminds me of it's really sort of an evolution, right? Because we've gone through this period in the security community where we've all very loudly said, like, don't have internet-facing things that don't have multi-factor authentication on them. Okay, great. But we've said that from a user perspective, and APIs are an entirely different animal because usually that's machine to machine. And we're sort of having that that moment, I think, now where we're like, oh my God, we forgot about that part, right? I mean, that part is something that we trusted the developers were doing the right thing, and so we're going to go through it all again, I think.
And I think you start to chain those together, right? You look at like Log4j, you look at something like this, takes serialized content or any kind of content on an API that's not multi-factor because it can't be, to a data lake or data center that's a back-end integrator to massive amounts of important data. And you really run into a perfect storm for attackers to pull a lot of info out of the network without having to traverse or even trigger any of the controls and visibility that you may have. Like, how are you doing visibility on your API?
It's interesting you say that, Tyler. Like, I'm working on some feature and functionality now to implement webhooks into my application. And I'm like, well, if I were to design this properly, I would allow the user to define the webhook endpoint of where they want the data to go, right? Hopefully on whatever endpoint is catching that data, like I'm leaving it up to the user to say whether that uses SSL or not, and whether or not there's credentials on there. Like if you don't pass credentials, why should I assume that I need them? Like, do I want to force the user to have credentials? And then I'm like, this is a great way to exfil data outside of my application. If I'm letting the user define the endpoint, how do I go look for a malicious endpoint? Like the user define that. Like you want to send the data somewhere, but I'm like, what a great way to exfil data in your example, right? Is to just configure a webhook.
And even gain insight to that, right? Like you look at like Conti's a great example. You want to see some fascinating socket proxy hula hoops with some amazing web sockets that passes onion and Tor traffic through SSH and SOX proxies on anonymous bots in a relay. Like you can do all of that very, very well, and they do it well. You start to think about how would you gain visibility into something like that as an enterprise? You don't really have control of that.
Yeah, that's like web sockets were made for attackers, not really for anyone else.
Man, WebSockets, I'm just going to say, WebSockets is where all the C2 is at. That's what we've all moved to, and it is that's how good sophisticated attackers are doing communication on the internet in applications in the background.
Yep,
all day.
I also want to point out that a lot of APIs that are written with various frameworks have self-documenting features. So not only can the attacker attack them, they can actually learn about documentation them before they attack them.
Oh, I think that's great. Is one thing programmers don't like to do is write documentation. Oh wait, I can run the script and it just documents my API for me. It's wonderful. Everyone now is documenting their APIs. It's great. It's great.
Which is a good point, right? Like if you're going to have to test these things, you also need to realize that you can't just get a regular pen test company.
Yeah.
You can't just get a regular web app pen test company. You can't even just get a cloud pen test company to do this. You really need a specific specialized API web tester that understands the full stack, understands the technology, and understands those other layers that integrate. Like you do need to know the cloud, you do need to know the network, and you do need to know how all this ties together while knowing the API and the nuances between those technologies.
You know, I was just, one of our new sponsors is Source Defense as well, and I was just talking to someone from there, and I was like, you know, me writing an application that has nothing to do with security pays so many dividends in security. And just understanding, because like I've sat in the developer seat and coded the application, and I'm like, oh, that's, you know, sometimes I complain about it, but I'm like, I really shouldn't, because this is great experience for security. Try and make it out, try and build an application and make it work that has users, right? I think it's one thing that I have other projects where like, here's a script, like, oh, do this stuff. That's one thing, but like, be part of a team that's building an application for users. That's, I tell you, people that want to get into this field and do specifically what Tyler was talking about, like be an API and web application security specialist.
Yeah, roll up your sleeves.
You got to do some building, right, Joff? I mean, you've sat in that seat.
No, that's absolutely true. You're actually making me want to. I'm in the midst of developing another class right now, which is going to be basically cloud / Golang DevOps kind of thing. And you know, the first thing was, I got to write a microservice that we can use as a model for the class.
You build an application to learn how to secure it.
Exactly. So I roll up my sleeves and I write the microservice. And I'm partnering with Andrew Krug, a friend of mine. But and I finish up the microservice and I post it up there. I said, there you go, Andrew. Start doing your cloudy thing with it, right? And the first thing he said is he writes back to me. He goes, your application is great, but it doesn't have enough bugs.
That's a
You've
compliment.
got to introduce more vulnerabilities.
That's a compliment. Like, well, because I think it's really just experience that teaches you to code defensively. I mean, because when you're in school and coming out of school and you think about where, if you've done software development for any length of time, I think one of the things you learn is to just code defensively, and that's just a lot of that is a learned skill.
You change your entire approach, right? I mean, it sort of becomes instinctual, and I was like, oh, so I am literally going to go back to that code probably tomorrow, and introduce an API call that is deliberately vulnerable to command injection.
Yes,
just so that we can show it up on
take out some of your exception handling. I delved back into our PPWorks code, and I started hitting points of it that I maybe had never looked at or just didn't spend time with. And I'm like, oh my God, this is something I haven't touched. I know, because there's no exception handling in this entire block of code. I'm like, that's really bad. You're going to get 500 internal server error.
Yep.
Damn it.
Yeah, exactly.
You turn some of your users loose, so you turn SAM loose on that.
That's it.
And that's, for a pen tester, that's followed up by, information disclosure vulnerability, right? Yeah, that's great.
Where do we want to go next? Let's stay on the
Auto
close
warp?
off some of the
Auto warp is probably a nice segue for the API stuff.
auto warp.
Auto warp. My story number 6 and your number 5.
Oh, this was the Azure one. Okay,
Yeah, the Azure one.
I did not read this one. I'll be honest. I totally just I flagged it. I was like, we should probably talk about this.
Yep.
And I hope Larry and Tyler got it covered. And now Joff is here too, so Joff can probably talk about it as well.
I did do some reading on it, but I want to make sure that I capture the appropriate names for language within Azure.
So this was discovered by Orca Security.
Yep.
Impacts Azure. User
I've got to ask the first principle question. Is it today, right? This might be the whiskey talking. Is it a real vulnerability if it doesn't have a logo and a fancy flashing?
I think it's a fair question. I think it's a fair question, Joff. I also think that it's real if it has an exploit. If you've proven that it can be not just theorized about it. I think if you just theorize about it, it can be debated. I don't care if it has a logo, a song, a dance, and a website. But if it's got an exploit, I can go pull down exploit code or follow some instructions to exploit it.
I was thinking about that with Dirty Pipes, right? I was reading through the source code and I'm like, holy shit, this is awesome. And you know what I know I'm tangenting with a go back here, but the thing about that exploit was it was made possible to exploit it because of a more recent commit in the kernel. I found that fascinating.
Yeah, it was 5.8 or later. So if you're earlier than 5.8 Linux kernel, you're not vulnerable.
You're not vulnerable. So it was a later commit that introduced a feature that made this memory page vulnerability exploitable.
Spoken like a true developer, it was a feature.
Put the Kool-Aid down, Job.
This one was different than the one I was actually thinking of. The one I was looking at was the Azure Resource Manager vulnerability, which lets you get like root level, basically a global admin on an Azure via the API connector. And this was put out by NetSpy. I'll add a link to it for someone to add, but since my PPWorks account does not allow me to add things still, I'm kind of in the middle of...
you should talk to the developer about that.
Man, I should really reach out.
I heard that guy.
But it essentially allows you to use like logical apps. Yeah, you can escalate from a logical app permission or role-based permission for a logical app and gain global... It's going to be global admin, effectively global admin permissions inside of your Azure environment. And so there's a ton of things that you can do right from just getting, and when we're talking about apps and subscriptions and what
is that like domain admin or
same thing?
Same thing, right?
Yeah, it's the same thing because you're a master of your domain, so to speak.
So I'm sorry, Tyler, in a hybrid environment, that basically it's like you're adding me to domain users, right? Domain admins, rather.
That MSOL account or AD Connect account. Those are essentially the sync accounts that allow the syncing of hashes and passwords between Azure AD and your on-prem environment. And so you can effectively gain the clear text passwords if you have that write or roll within inside of Azure AD, or you own the server or the account on the on-prem side.
Wait, you can gain... It actually allows you to view users' passwords in clear text?
Just exact same thing as like a DC. You have that get all replication rights on the domain, and you can do DC sync, DC shadow, those kind of things, both directions based on where you're at. So yeah, and this is one of the problems with Azure AD and how tenancy works is you end up with these subscriptions or these applications that users can grant roles and accesses to your environment unless you lock that down very strategically and you do auditing across all of that, by default, that is handled and allowed to, some of those apps are allowed to do a lot of things that get very interesting. And
you mean like add email rules and create mail folders?
I mean, that's just the base of it, but yes, 100% right there. That is how a lot of places are using it.
Yeah, Tyler and I saw that firsthand. I was like, wow, that's a neat little trick. And really, like you said, Tyler, like sometimes all you need, if you've got a foothold in the domain, you can access inboxes and create rules and create folders. You can start intercepting things and you're off to the races.
And once you get that token or that service principal account and you gain that access, like the persistence in the way that you can add yourself and do interesting things with applications and subscriptions becomes really hard to track down unless you have someone like Trimark, Sean and Christina over at Trimark have written the book literally around how to audit and look at all of these myriad of roles that happen within inside of Azure and look for the things that get evil very quickly. Otherwise, it's very difficult.
So, I mean, what was the tool you had me run that audited the environment? What was that called? Hawk was awesome for that. I mean, but you still have to know what you're looking at. Like, I'm not the expert at looking at AD logs and all that stuff, but like, I don't know, I've been around security for a while, and I'm like, Tyler, I think it's that. And he's like, yeah, it's that. I'm like, I don't know what that is, but I know like that looks like it shouldn't be there kind of thing. But I think for really practitioners, right, you've really got to study that and run tools like Hawk and audit your environment and know what you're looking at.
Well, and a lot of good apps and a lot of integrations, and even you look at the APIs and integrations to things like ServiceNow and Jira and all those things, like those, even Teams, those resources and roles and subscriptions that happen inside of Azure have very specific permissions that could look nefarious, but you don't know. They have to be there, at least by default.
Yeah. So, Larry, your story was not about what Tyler was talking about. Your story
but I can. There were sort of lots of parallels there. So effectively, the researcher at Orca was playing with the automation accounts. Under the management and governments category within Azure. So you couldn't effectively deploy code, PowerShell, Python. First thing they did was to deploy one that would give them a reverse shell, so they could then explore. Started trying to run commands and it wouldn't work so well, and was getting some errors. But there was a log file there in one of the directories that they had access to. Taking a look at that log file, you start seeing messages about along the lines of, "Hey, we tried to get you some output, and we created the asset retrieval web service at this high port number, and then something failed. So you couldn't get any assets." And noted that it was random port numbers above like 40,000 every time. And turns out that it was just a random port number, but it was coordinated across multiple customers. So you start exploring that random web service. The root doesn't give you a lot, and then you start playing a little bit. But if you were to ask for something like at that web service, OAuth 2/token, go, oh.
You get a JWT, don't you?
Yeah, you get a JWT bearer token for not your service. So, yeah. So using the automation service, they created a scanner that every hour would go through and connect to all the like, it was like 1,000 ports, starting at port 40,000 once an hour. At the top of the hour, go connect to 1,000 ports and see what tokens they got.
This actually should not just affect Azure. This should affect a few things. This should affect AWS's service. What the hell is it called? Superglue. And another one of Google's things. This is bad. Now
it's been patched at Azure, so they fixed it. They fixed it. Yeah.
No, it's good.
That's awesome. JW2 is very interesting. The bearer tokens and like your ability to decrypt those. Actually, Corey wrote a tool called Jwt Split, and you can reverse that. And if they didn't get the HMAC right and the encryption portions right, you can actually make your own things, renew JWTs, get information out of those JWTs like this.
Yeah,
why didn't you tell me about this 3 weeks ago where I had to exploit JWT?
We did a couple of. You should ask that. We did a couple of segments on it. If people implement them poorly, JWT is like a complete joke. If you implement it right, it's not horrible.
JWT is good. Yeah, if you get it right, it's.
But you got to get it right.
You got to get it. Yeah, you got to get it right. In this particular case, of all the tools that I was familiar with and had been taught about, they got it right.
So, Amazon Echoes hack themselves.
Yeah, like to me,
this one was.
I love that.
This one was a brain kind of teaser. Like,
it's like a misnomer.
They fixed some stuff. Like, there was somewhere you could, if you had a phone with Bluetooth and you issued a command to an Echo device, you could make that device connect back to your phone and control it?
No.
Is that true?
So it was, if you had and the way I read it is, if you had an Echo device and you had a phone with Bluetooth and you connected to the Echo device to have it play audio as a Bluetooth speaker, you could play commands to that. You could have the speaker play the commands, which would then be received by the Echo, which would execute it. And sometimes you needed to say a yes, so the answer was you put a 6-second delay and you have it that your radio station say yes after that. So it was, I don't know,
it was wonky. I couldn't it was tough for me to follow what I'm like,
how do you get your Echo to play stuff that your Echo can hear while taking commands? Because every time I talk to my Echo when it's speaking, and I say the trigger word, it stops what audio it's playing.
It says it requires only a few seconds of proximity to a vulnerable device while it's turned on, so an attacker can utter a voice command instructing it to pair with an attacker's Bluetooth-enabled device. As long as the device remains within radio range of Echo, the attacker will be able to issue commands. So that Bluetooth connection to my phone acts as a microphone and
I guess
allows me to execute the Amazon Echo commands through my phone.
Yeah,
it's kind of wonky. It's kind of wonky. So
that's kind of like
so much like
that's kind of like the Bluetooth thing for Ubiquiti, right? Like if you're within range of most of the Ubiquiti devices, they have the Bluetooth configuration model from a mobile phone.
Right.
And if you don't turn that off after the initial configuration, like you can access it and begin initial configuration or tell it to reconfigure itself.
Yep.
Which that's probably not a good thing. And usually it shuts off, like now by default it shuts off after you configure it the first time, but there's some interesting things you can do to get it to reset itself and get into that pairing mode that, if you have physical access, that's a problem.
Yeah. Yep.
Well, I mean, that's a general problem, right? I mean, you got physical access to any compute device.
Right.
Game over.
It's a problem.
And now it's starting to become more not physical access, is becoming
I was going to say,
close
you start to look at some of the Conti stuff and the UEFI or flash drive level boot kits that Eclipsium is going to come out and, they're going to offer some amazing research here very, very soon. The level at which the actors and the sophistication is getting, it becomes a much different scenario where we're almost at that point where you look at something like IPMI, where you're getting that level of persistence and that level of physical console access that maintains its presence on a device outside of the OS, the security tool stack, and what visibility it can gain even after the OS starts. Because, you talk about a kernel level rootkit or Ring 0, you can tell it what it can see and can't see, and there's no way around that if it's getting loaded on boot at the earliest level. So that's going to be...
Yeah, I mean, what it comes down to is that we've taken the physical hardware requirement for that software control plane and extended it to being networked. And once you do that, right, you are opening up... You are, in fact, eliminating the physical proximity. You're putting that thing on the network.
Which is where TPM is really going to come into play, right, Joff? Like TPM and Windows 11 and the integrity of your boot process from start to finish at a cryptographically secure means becomes very important. But you also start to think about where the flash drive and where UEFI comes into that TPM process and what can get injected midstream.
Well, exactly.
If it's implemented properly, that's a problem.
I mean,
Yeah,
like
exactly, right?
So, I mean, some of the problems.
Whoever came up with that idea?
Yeah, HP addressed.
I'm sorry, Paul. Go ahead.
Stepping on you. Sorry. Continue.
Oh, I was just going to say, I mean, when that first came up, when people were saying, okay, I can flash my UEFI from a user space process in my running operating system, all of us in the security community went, that's an incredibly bad idea. That's an awful idea.
Yeah, but it's more usable.
Right. But we knew that, okay, now it's just automatically exploitable. Like, congratulations, well done.
Yeah,
and that doesn't even take into account like our next level of concern, which is where Eclipsium is like so far ahead of the game. Like, I just don't even think people realize what they had done in the initial point. Like, we've got a supply chain issue now where we can't even get a hold of the virtual level of UEFI and pre-boot, pre-OS visibility and integrity. Now we're talking about supply chain and what can get integrated on GPIO pins that are undocumented and calls at the stack that are undocumented and chips being shipped with firmware that have the ability to bypass a lot of the security controls. That's a bigger problem. Like,
and we
haven't even gotten to that.
We have two examples of that in our stories this week. One is HP addressed 16 UEFI firmware flaws. Attackers can leverage them to perform privileged code execution binarily. I'm sure there's only a few companies that do like fully automated firmware vulnerability detection. Binarily, I'm going to call it because I can't say it anyway. Is one of them.
Sounds very Californian of you.
Yes.
And this is exactly what Conti was using and developing as part of their perma DLL. So
the other one was TL Storm, not UEFI but firmware based, intercepting the TLS handshake. TLS authentication bypass was one of them. Essentially, these are APC, a subsidiary of Schneider Electric, of course, UPSs that have firmware on them that connects back to the cloud to get firmware updates and receive configuration. They were able to sit in the middle of that and basically load firmware and get remote code execution.
So even though they were doing the right thing by validating using TLS and verifying the firmware from the cloud and the signatures of that, if you man in the middle of that and you can do that at the chip level, you've lost the chain of trust at that point, and they can do whatever they want.
Yeah, so one of them they describe as a TLS authentication bypass. A state of confusion in the TLS handshake leads to authentication bypass, leading to remote code execution using a network firmware upgrade. And then there was a memory corruption bug in packet reassembly. That looks like a straight RCE. And then there was a third CVE unsigned firmware upgrade that can be updated over the network, which essentially they're calling remote code execution.
You pulled all those together.
If you're going to load whatever firmware I give you as an attacker, like, you're going to run my code. Thank you very much.
That's not.
And
good.
now you compromised the UPS layer, which for denial of service.
Click.
Yeah.
That's bad. So what state were they in when they did this?
Push button DOS.
A state of confusion.
A state of confusion. They were in the state of confusion.
I mean, you think about that, though, too. Like, a UPS is also one of the few places, if it has the ability to maintain that code, interact with the system via direct calls. Because it's UPS, it needs to be able to turn that system on. It needs to be able to interact with the BIOS. And it's got certificates embedded into it, so it's got some smart capabilities. That seems like a great place for persistence in a long-term...
So,
who's looking at it?
These UPSs seem like they're really large UPSs that are connected to high voltage power. Armis is the company that found these vulnerabilities.
Probably.
They said they were able to ignite them and make them go up in smoke, likely by turning them off and back on again and repeat.
Well, you change like a phase, right? Like you think about going from like a delta to a Y phase on something like a 13.8 high voltage 3-phase direct connection to a transformer. Like, these transformers have these data center connections that also need the ability to fail over to a backup. That backup has to be of same capacity to handle the data center or a crypto miner site. And those two things need to be in parallel and be in phase so that they can fail over live without losing downtime.
Yeah, they didn't publish exactly how they make it went up in smoke, but one can theorize.
So the TLS confusion was a buffer overflow that was exploiting a memory corruption bug in packet reassembly. Is basically what's happening there.
We still have problems with packet reassembly
and memory corruption. I mean,
memory corruption is can you believe? Well, these TCP stacks are really simplistic on these devices, right?
Yeah.
So I've got to ask this first principle question. Why does a large UPS need to be connected to the network the whole time? Can you not just connect it for the upgrade and then disconnect it?
But how do you know there's an upgrade?
It's usually because of high availability. You have to have the software dynamically interact with the UPS in order for that phase change to react in a millisecond so that the current can then be passed through and uptime is maintained to the devices that are off of that. That's usually why.
Okay, so I'm going to ask a bunch of dumb questions having not read the article. Why can't the appropriate network defenders control exactly what that APC UPS can talk to and what it cannot talk to?
That's a great question, John.
They probably can. It talks back to the APC cloud, but some of
we need BACnet. We need to be able to remotely manage these out in the middle of the boonies with some BACnet.
Yep. I was going to say they probably can, but they don't.
I love how Tyler's playing point counterpoint with me.
But I think if you get on that same network, Joff, you can man in the middle in between that APC UPS device and the cloud and get in the middle of that TLS handshake.
Sure, but you want to raise the barriers as high as you possibly can, right? Because you're going to have vulnerable infrastructure devices. So it comes back to that whole defense in depth idea. I know it sounds like an old term to people, but it's still applicable.
Yeah,
right? You're talking about OT, right? Like you're talking about ICS, OT, and facilities. People that understand the ability to deploy high voltage transformers at the proper phase with the proper length and connecting it to a system. Like that's all OT. That's all building facilities. That's all.
Yeah, I get it. I know what. Right. I get it.
Well, you're barely at 13 kV. You're barely in the high voltage scheme. Tyler. You just started you're at the bottom of high voltage at 13 kV.
I'm just touching the transformers.
You're not getting
I'm
to
not
the big
sure.
boy
This is the SMT series. I'm not sure what how far those scale up power wise.
They scale very, very large.
Sure, it sounds like they're really big machines, but they can handle the higher voltage that you guys.
These are multi-million-dollar devices. These are not just
it's not the
300,000.
1500 APC 1500 I put on my desk at home.
This is not stuff I stick in my server rack. Right?
But that said, if they make the mistakes on the multi-million-dollar thing, do you think they're going to make the same kind of mistakes on their $300 thing?
Larry, you just had to say. Of course, they make the same mistakes. Come on.
They probably make worse mistakes, but that's something else altogether, right?
I mean, at least a direct connect USB or NIC that runs on a COM port with Telnet.
A couple of like policy articles. The Cyberspace Solarium Commission, which I think they did a really good job. Have you guys heard of the Solarium Commission?
Yeah, that's I've never heard of that.
That's Jim Langevin's project.
Yes, Jim Langevin was on the Solarium Commission. Yep. And the work that they did ended up becoming law. Which, I mean, look, in politics and government, there's a lot of people that get together, right? And they try and make policy, and it doesn't always become law. Dave, I'm sure you've talked about policies and in the state and government here in Rhode Island and things like that, right? Like not everything goes everywhere.
No, but it's also literally frightening when you go up there to try to testify in something technical. Right? I had to testify in a web filtering bill that was put in by the ACLU, and they had no idea what they were talking about.
Right.
And then it's for the kids. You have no idea what you're talking about. You're giving the rights to parents to change, essentially, whitelists and blacklists and on demand. And it's like they have no idea what they're talking about. And so if they don't really fundamentally understand the technology, then the policies are frightening.
Yeah. I think they created good policy coming off of this. I've heard good things about the Solarium Commission. They're still working on policy. It looks like it's been kind of scaled back a little bit, but they're turning their attention to water, maritime transport, and healthcare sectors. So hopefully they continue to make policy that makes sense. That's the thing with regulation. Like, you're going to get regulation whether you like it or not. If you're not involved in the process, you're going to get regulation that doesn't make sense, and that's not good for anyone, really. Well, maybe it's good for people that want to make money off of it.
My biggest fear in the world of quote-unquote, and get ready to drink, cyber regulation is overreach, because I think when you get an enthusiastic congressman or senator that actually thinks they have a clue, and I'm talking federal level now, obviously, but it could be at the state level too. And then they write something that's too prescriptive, that can be extremely damaging.
It can damage innovation, certainly.
I absolutely agree on that web filtering testimony that I gave. I had the bill in front of me. I went to the commission and I said, I agree with the title of this and nothing underneath it, because if you actually implemented underneath it, the state would have lost $3 million in federal funding because they would have violated the E-rate pro formas that pay for all the technology in the
Most
schools.
people just read the title, Dave,
they didn't,
right? Yeah.
They didn't understand what they were doing, and so you're absolutely right. The overreach is the thing I absolutely worry. I don't think the Solarium Commission at the level that they started at, I don't think they overreached.
No, I think they made stuff that made sense. I don't remember the details, but I know that. Yeah,
it was pretty high. It was pretty high level, and now they're saying, let's go to really critical infrastructure and make sure that we know what's.
I'm assuming they're working really closely with CISA at this point. If it's people infrastructure and the people that are going to have to enforce that, validate it, test it, provide recommendation, remediation, and give the commission its teeth and or its ways to get to these levels. It's got to be part of CISA.
And CISA is being very good, and I want to say generous, of helping the have-nots in the state. So, for example, you take Rhode Island here. We got 39 cities and towns, and their IT departments are, come on, they're not going to do this stuff,
one
right?
person at best.
So they can't even do an assessment. And so CISA is actually coming along, and them coupled with things like MSISAC and those kinds of things are providing, free tools that are at least getting them to the next level, because they had nothing.
Free tools and assessments.
And assessments.
And assessments. I mean,
and hopefully prioritizing those 39,
well, have you?
That being said, there's a huge gap there, right? Like we do need to call out the fact that yes, CISA is doing a great job. We're seeing lots of stuff, but that's because a lot of people are committing to CISA, committing to the mission. Maybe taking pay cuts, maybe not. Like those things are super important. So if you're looking to get into the space, you're looking to move to a better mission, like make sure you're considering them as a viable opportunity to contribute something back that is meaningful and doing really good things, because they're so short right now and there's a ton of billets open for any of the work that they're doing.
Yeah, and Mike Tatros, Rhode Island guy.
The sad truth also about it is, you talk about it at any one state level, small town, small village. If you replicate that across the United States, the vast majority of these small municipalities, it's thousands and thousands of them out there that that is the biggest problem. It's not these giant corporations at the top who've got their act together.
Well,
that's where it's at.
And a lot of it from a policy perspective or a local perspective comes down to the fact that we're not organized to solve the problem. So if you turned around and looked at Rhode Island, we got 39 cities and towns, 39 municipalities. By the way, the municipalities don't like the school guys, so they don't, even though they're part of the town, they have two different IT departments and two different data centers.
So just double that, double that number.
And
fiefdoms and silos.
And then along comes the Secretary of State's office and says, I want to do election security with the municipalities, but they have no jurisdiction, right? So there's nothing from an organizational perspective to actually do something holistic. And if anybody could do it, Rhode Island here, right? We should be able to do it in Rhode Island, and we can't.
39 cities and towns, like that's the most Rhode Island saying I've ever heard.
Right, I know.
There's only that's it.
That's it.
Lee, it looks like you had something to say in there.
Well, what I was worried about is, we had a commission that was congressionally directed and funded, and they're now a think tank working on their own, getting their own funding.
Good observation.
I'm just wondering if they're going to have the teeth they once had. Are they going to still have? I mean, they've got a reputation and they got excellent folks working for them. I'm not worried about the credibility. I'm just not worried. I'm worried about the clout. Are they going to have what they need?
That's got to be their connection to CISA, right? That's got to be their relationship and interoperability between departments, which CISA seems to be doing a great job of being able to collectively gather all of these disparate federal agencies, federal beneficiaries, federal money to kind of bring people together, at least underneath of a single pane of like, hey, you can ask CISA, CISA will direct you to the appropriate place to go. But
the corollary to your question about whether they're going to have the cloud is whether or not we're going to have the money, and so I mean because they could turn around with the cloud and then it's an unfunded mandate that has to happen, and so but I actually have some hope on that end because of the amount of money that is coming from the federal government to work on these things. So there are tons of opportunities for cybersecurity advancement buckets of money.
But that does depend on our elected officials, though, right? Like we really have to keep that forefront. Make sure that
it does, and I'm trying here in Rhode Island because there's money. There's $100 million coming to every state for broadband for the underpinnings of what it is, right? So there's $100 million. Well, you have to have a broadband office to actually do that. Well, Rhode Island doesn't actually have one. So it's on the elected officials to actually create an organization and a group to actually accept the $100 million so that they can dish it out the right way. And you're right. We gotta have people that actually can do that.
OSHAN should do that.
We should. Right?
Well, I mean, certainly operated in similar kind of grant money and making sure that goes to the right nonprofits in Rhode Island. You have a history of that.
That's what that is what we've been doing, and the other part of it is that we make a lot of glue, holistic glue, to our member community. So while I do 12 individual state networks, so like the AG's office is different than the secretary, but we do that from a common infrastructure and architecture. We just don't tell them.
Right.
So they think they have their own fiefdom, but they're actually working.
That's a really interesting comment because I've watched that operate here in North Carolina too. I mean, the research and education networks that are in the states do have a lot of influence and do have a lot of ability to affect change there, but a lot of it is focused on the sort of K through 12 and tertiary education space, and how much they reach out of that. It
depends on the state. Here with OSHAN, we do also the healthcare industry, and we do state and local governments. Some of the other ones in other states don't do that. They stay either in the higher ed.
Yeah, it's the same case here, right? I mean, Mark here down at MCNC, and they're doing the same thing. They're reaching out to hospitals and state and local governments. So the reach is much wider. But other states in the union don't do the same thing. But it's almost like we need to just sort of last mile connect that to the small medium business that can't take care of themselves. There's that gap there.
Yeah, it's an interesting battle because once you end up in those spaces, the incumbent providers get kind of upset.
Yeah, because you'll take business.
And then everybody gets angry.
Yeah.
Yep. Everyone should be angry about Article 45.2 from what I've read. Mozilla and the EFF published a letter about the dangers of Article 45.2. It reminds me of the Clipper chip. And so proposed EU legislation, mandate support for a new kind of certificate called a Qualified Website Authentication Certificate. They would be issued by the trusted service provider, which is really just a CA. They're not approved by, so those TSPs being approved not by the browsers, but rather the governments of individual EU member states. Browsers would be required to trust certificates issued by those TSPs, regardless of whether they would meet the root program security requirements, and without any way to remove misbehaving CAs. Like, to me, that's just like the SSL equivalent of the Clipper chip. Like, that's
I was going to say dead before birth, right? Haven't we learned enough since Australia tried to do this recently?
But there are
come on.
nations that do this already, right? Like,
Sure.
what is it? Is it was it Kazakhstan that does this, or one of
Yes,
the Stans that does that?
So they basically have a CA that's in your browser that you can't remove, so they can
Yeah.
intercept all of your SSL TLS
So
traffic.
nation states can meddle and do whatever the hell they need to do in order to provide offensive and defensive oversight.
Yeah, what could possibly go wrong?
Terrifying.
That's just a bad idea.
Speaking of certificates,
Yes.
Paul, one of your stories was that the Nvidia hack.
There was a lot on the Nvidia hack.
The Nvidia hack.
Oh, yeah,
your
Kim
Idea
signing
stolen
abuse.
certificate hack.
yeah. The
Was it one of my
certificate that
stories?
was stolen is now being used to sign malware.
Yes. There's not just one.
There
Not
are
just-
two.
Maybe there's more.
Well, go for it, Tyler.
No, I mean, and they are expired, they are revoked, but the fact that you're signing code with a valid cert allows that code to be recognized as signed code without the revocation as part of its trusted cert execution policy.
Sorry, this was
So-
Lee's story.
I was
That's
going to
a
say, it
problem.
must be one of Lee's stories, yeah.
So
There is a
part of-
tremendous amount of interesting things that can be done once you get a signed driver into the kernel. I'll just say that.
And getting a signed driver is not even that difficult. Like, it has gotten a little bit harder, but a couple of business entity papers, some forged documents, like you can definitely get one of these. But the level at which NVIDIA's certs are represented at the CA level becomes a very different threat model, and the timing of these certs also becomes very interesting.
Lee.
Yeah.
So the interesting thing here is that although these are in fact expired certs, one expired in 2014, the other in 18, Windows allows for drivers signed by these certificates without an expiration, without a timestamp, to still be accepted even today. So it doesn't have to be a valid cert. There's no krill check. And and it actually works even in Windows 11.
And that's because that's NVIDIA?
Yeah, it's actually Windows. It's a backwards compatibility. So that you're rebuilding your system and you need that driver for your video card that's been sitting in there for 5 years. You gotta get get that driver. They don't may not be able to
I see. They want
They're
your
not
video card to
enforcing
work.
the expiry date.
right.
That's
So
terrible.
it's actually any driver signed by these.
Or that software is a legacy software. Like, once that's signed, that makes the certificate, like, you can actually set permissions and there's security controls around this to validate certs for signed revocation and revocation checks on execution. Like, those are things in Windows.
Oh, wait. So
But,
you can set that, Tyler, so that if the driver's signature SSL cert, right, or the certificate is expired, don't accept that. And that can be a Windows policy, which means maybe my graphics card doesn't work when I get into Windows,
strict driver
which would be
enforcement
bad.
control.
Which would be bad. I mean, that's a bad day for a user.
Yeah, strict driver enforcement control, and like Windows S tried to do that, and Windows has had this for a very long time. Like, by default, yes, Windows is very much geared toward the compatibility. It's changing, but the ability to secure this and have that granular control, you can 100% control which certs you allow, which CAs you allow, which manufacturers you allow drivers and signing and driver loading into the kernel. All those things are very much controllable by GPO and or audit policies. So you can get visibility on it and you can block it.
Right.
Yeah.
But you got to take action.
This is what ransomware has been doing this. In fact, we see it in the Conti and the Bazaar bot loaders. With inside the source code of that, we can see that they're signing all of their stuff. So it is not a new thing. It's not something like we do that for pen tests and good loaders. You want to make sure your stuff's signed. And malware people
I was going to say, Tyler, though, when you bring your own driver, which is what you're talking about, BYOD, right? You need that initial local privilege to actually get that driver installed. But once you get there, then game's over at that point.
Right.
You do, unless you set there's a user load flag where you're just leveraging the cert to sign the code that validates the code is a valid code snippet to run underneath of user space. So you don't even have to use the driver. You can actually sign loader code, which is just a DLL or binary or shellcode. You can sign that code to be ran with a driver cert by an authorized code signing cert.
Oh, that's kind of fun. Okay. Sorry, Tyler and I went down the rabbit hole of thinking.
That's good. Tyler, you played soccer, right?
Yep.
I think those of us in the U.S. may not realize like how serious football, as they call it, right? But here in the U.S., we call it soccer, is. And like, two of my sons now actually play soccer, one competitively, and I'm like, wow, this is like, I never realized. Like, I played baseball growing up, I didn't play soccer.
It's a religion.
It's very serious. And it's growing in popularity in the U.S. I think it's a positive thing. Many cities and towns here in Rhode Island, right, have increased the number of kids that are signing up and playing soccer, both at the city and town level and at the competitive level, which I think is a great thing. It's a great sport for kids. It's wonderful.
It's very cool. Highly
competitive. Like, I studied Kung Fu, and I knew that, like, in China, when you study Wushu, they'll send kids, like, 6, 7 years old, and they go to school. But mostly they're training in martial arts and Wushu and also learning at the same time. And that's where they live for the majority of the year until they go off and compete at the, national level. Soccer is very similar in other countries, especially outside of the U.S., where that same thing happens. Like, kids will go there at a very young age. They'll live at the school. They'll study their studies, but mostly they're playing soccer for like ungodly hours a day. So,
like military school.
Yeah, pretty much. And so this social engineering tactic I thought was kind of interesting when you look at the lens of soccer. So one of them was, this email was sent to soccer clubs. So like soccer clubs are not like, I'm getting this with my kids in multiple sports. Wrestling is very similar. Like the middle school and high school level is like one level of a competitive thing. But really, if you want a scholarship to go to college, you have to compete on like the national tournament circuit. That's where you get into a soccer club where you compete at that tournament. So this email is like sent to soccer clubs, like, here's video files with YouTube links showing highlights of players from where they say it was like South Africa was part of the ruse. And so here's the link to the footage. And then they were instructed to download and enable a Microsoft Excel document infected with malware. Which that to me was a little bit of a stretch. I don't like. What do you see? Player stats there, like that was part of the ruse.
You've got stats to upload. Like, no, 100% as part of like a semi-pro club. Like, I have to upload my stats each game as far as like how many assists, how many goals you have. The club uploads them; those are matched. And
so this is like more of a legitimate ruse than I thought.
No, yeah, 100%. Like, and the fact that it's in a spreadsheet, like maybe it's just a little bit lower end club. Like maybe they don't have the full web app experience or mobile app to upload your stats. But as part of the recruiting, you're uploading each of your games. You're uploading your highlight reels. You're uploading your stats for that season, for not just the club, but for your post-competitive club and your extracurricular club. You've got.
But also in wrestling, we do a similar thing. So like one of the tournament circuits that one of my sons started competing in, you have to get a USA Wrestling card. You have to register with that tournament circuit. And every time you compete in that tournament, every single match that you did during that, every single tournament is recorded, who you wrestled, how you won or lost, or whatever the stats are for that wrestling match is all recorded in your history. All
historical, maybe even with video. Like those are part of like either running semi-pro or even getting recruited. Like in order to go try out for the pro level, like when I showed up, you have to bring your pro tryout card. You've got to show the stats that you're pre-approved and that you're able to qualify in order to show up to open tryouts. And that's all part of it.
Yeah, in tennis, USC, if you're part of USTA, all my matches are recorded. And it's all uploaded, and that's what creates my rating. For tennis, so I can when I go to tournaments, I have a specific rating. Right. And all of that's just done through an app.
So it's it's pretty legit.
And the club itself, forwards the scores of my matches, right? So it's it's
ubiquitous.
It's ripe for phishing actually across multiple sports. Yeah.
Clubs and sponsorship and the amount of money that comes into clubs and how those clubs work, like between trainers, salaries, the sponsorships, the stadium, the facilities, the traveling team, the booking, all of those things play into any soccer club, not even at just the pro level. So that's a pretty legitimate attack, honestly.
Yeah, so this was the 5 strangest social engineering tactics of 2021. That was the first one.
And more legitimate than you thought.
More legitimate than I thought. So that one ranks higher with me. This one was interesting. So you receive a message informing you that your employment was terminated, but others got news of a promotion or that they received a holiday bonus. You download this Excel file and click the enable content, resulted in a Trojan being dropped on your computer. I think what the icing on the cake on this one is if enabling that content lets me see who was fired, who got a promotion, and who got a bonus. Right? If I can see that, I'm going to click it. I want to see I want to see all this, right?
Add one variable to that and have a bunch of CCs on there and do an accidental email and say, I'm sorry.
Oh, I'm sorry. Please retract that.
We accidentally added you to this list.
Yes. And then you're 100%. Definitely 100% clicking on that file, opening that file, clicking that link. Yep. And then there's the classic, like, hey, you won $100 million. You just got to send me $100. And then, like, I'll send you that $100 million that you're entitled to. I mean, that's more of a classic.
It's still going on. Like, that means it has to be working. But, like, my grandma won't even fall for this. So, like, why?
Yeah, that last one was the lamest one, in my opinion. The second one in there, the employee termination one, that's probably the best one. Yeah. To me, that's not strange. That's just like you will get people to click stuff. Yep.
Work from home updates, quarterly bonuses, holiday food drive and toy drive for Christmas or Thanksgiving.
Insurance open enrollment.
Yeah.
And we're just like completely negating any kind of security awareness and training programs that exist out there. Like if you really got to get someone to click, it's all up to your creativity. You're going to get someone to click.
Yep.
Yeah.
Yep.
Yeah. There's interesting ways. Like you always play to the psychology, you'll always get the end user click. Again, that's why we do not. Our users need to be trained, they need to be educated, but they're not our end solution. That defense in depth, like we really have to have technological controls there to support their inability to make decisions that most technological people probably wouldn't be able to make.
Yeah, I agree. You got to raise the bar. Like I remember doing phishing back in the day, and I'd be like, here's this PDF file. And they're like, oh, that didn't open. And I'm like, crap, that exploit didn't work. Like, let me try a different exploit. All right, open this one. Oh, that one didn't work. Let me try that. And like on the third try, she's like, oh, I got this one to open. I was like, thanks for helping me test all my exploits and which one worked. And, you know, I feel like technological controls have gotten better. The awareness and training has gotten better as well.
Yeah.
But there's still pretty easy paths.
Yeah, users are going to click. Like you get the right ploy. Like you send a hotel reservation in, you know, the opposite gender sex if they're married, and you put their spouse's name on that. Like I guarantee they're going to click on that hotel reservation. Like it just that's psychology 101. Like you can't blame them and you can't expect them to see that.
And that's the point. That's a good point because of the personality, you know, of the person who's getting it. And then so, you know, my controller gets an email from me, right?
Transfer
and it says,
this money.
Transfer this money, that kind of thing. But then it said, code it to our G&A account, right? Wow. So it went into a level of depth, you know, on the coding,
lingo.
Right? Yeah. Lingo of the finance department kind of thing, and wire it to, right? And so the backstop that we have is not technical.
It's process. Yeah.
It's process, but it's not technical.
Right.
So physically,
he or she calls
myself,
you, right, and goes, wait. Anytime there's a wire transfer, I don't care what the person said, is called Dave on his cell phone.
But she prepped it, right? So she was ready, right? But she did go to the physical side, you know.
Business email compromise, there's no way to stop that without people interaction in that business process and procedure.
I agree. That's the best. That's the best defense because like you said, Dave, someone is going to go through great lengths to construct that particular piece of fraud, right? But it's only the verification steps you do as a human being that's going to stop
my guys went crazy on that thing. They went after, so they did traces on everything.
Yeah, and
they found, so it was the code to PNC. So we went to the PNC Bank fraud department. It was some guy who was in Ohio who was having money routed through his account, right, as a transfer, but it never changed the balance on his account, so he never thought anything was wrong. Right. It was like you know, a retired store clerk kind of guy, and he had the same amount of money in the bank account the whole time.
Using
they were
his
just
account.
using that as the routing account, right?
Right.
Yep. My guys
don't. That's a great point, though, Dave. Don't trace it back to like the account the attackers are using are likely not their account. Tyler taught me that most recently. I'm like, wait, who's this person?
Right.
He's like, that's just someone they got a hold of their account.
Yeah, that's their money mule. Right. They don't know they're a money mule.
That's their shell.
And then they routed the person who was making the conversation. They routed that guy went up to Canada, came back down, and they had this nondescript door in Virginia, and they routed it all the way to there, and then obviously we handed over to the police and stuff like that.
Right. Usually,
money laundering is not as easy as it sounds. Honestly, like even with crypto, it becomes very difficult to do it without attribution and to get it from crypto to fiat. You're talking about a lot of hoops and a lot of cutouts and a lot of lost money. So it's not straightforward. You can always trace a little bit, but you probably lost your money.
Yeah.
So speaking of doing a little bit of tracing, Ukraine.
We haven't talked about the conflict in Russia in Ukraine in this show yet. I purposely didn't add a ton of stories.
I didn't either. But
there are. I mean, we talked about it last week too. I just want to put that out there. There are other major companies, technology and not technology, that are pulling out of Russia essentially. So
well, I've been watching all the anonymous stuff.
Yeah,
and Anonymous has been going after him.
Just seeing what they're going to do next.
The one that I think is absolutely fascinating and just stupid is that the Russians did it to themselves. Specifically, they had a whole bunch of secure communications that relied on 3G cellular networks. So what do? They go blow up all the 3G towers
in Ukraine.
And now they can't communicate.
Because they were using those same
C2
towers.
down.
Yep. So Tango down, right?
So because they have troops in Ukraine, obviously, they have cellular communications. So
their secure communications method is one of their secure communications methods is using cell phones over the 3G network.
I love it. They dust themselves,
and they blew up the 3G network, but the 3G network still works. Why? Ukrainian military and Ukrainian folks stood up Stingray. Devices
and or POTS, like they were leveraging POTS, POT telcos, and that's how we intercepted the general deaths.
That one, my understanding was Stingray. A Stingray tower stood up with so with 3G you can do a couple different encryption types. A51 was the quote worldwide standard. That was the one that Hakari had broken. But you can configure it as A50, which is unencrypted. So all you do is you stand up your Stingray as A50, and you have unencrypted communications.
You have they're not encrypted at that level
on the wireless side, but on the back end.
You can encrypt, you can use the unencrypted communication channel to you encrypt it before, like PGP.
You can do that with a nice radio that does both sides of that if you're close enough and there's no antennas available.
Blade RF. Do all of that with that, but hey, we use 3G for secure communications. Let's go blow that shit up, and hey, it still works.
But also I think one of the information warfare, cybersecurity-ish plays on that is, Lee, your story number 2 is the disinformation campaign that's happening against their own Russian people. Like, there are folks that we know that, are of Russian descent that have Russian family members still living in Russia. And they're like, some of my family is totally brainwashed. And they're like, it's not even their fault.
Right.
And because they're only getting the information from the Russian government.
But that's why Anonymous hacked the broadcast.
That was one that we talked about last week. Yes, I agree. That had some impact.
And you said that last week, I think it was Paul, was you, that of all of the things that the Anonymous folks did was the single most impactful thing that they did was to be able to put Ukrainian news broadcasts on Russian television.
Right.
Now, arguably, the stuff that you are probably seeing on Ukrainian news broadcasts are information warfare in completely the opposite direction.
Right.
So
it's exaggerating.
You're replacing one extreme with one extreme. And not that in that particular case was a bad thing, in my opinion.
Well, I mean, you've got a society who spent how many decades controlling the media and the message?
That's their shtick, right?
Right. I mean, you think we're doing it here? Comrade, hold my beer, because they know how to do that.
Yep.
Yeah, I mean, at some point there is talk of like a Great Wall for Russia, and they're already working on like how to implement that with some tips from their Chinese friends. So we'll see what happens there, because the ICANN space and Aaron space for Russia is very interesting in how the government has visibility and has the ability to look at certain aspects of it, and that's why they haven't shut that space off. And most of the sites there are not actually bad. If you're talking about a ransomware game or a criminal nation-state gang, they're using stuff out of Canada, they're using stuff out of the U.S., they're using onion sites, and they're using redirectors. Like, none of this stuff is hitting the RU space, so the people that are suffering are not usually the Russian people that are attacking the United States. So
there were some ISPs that were trying to pull out from Russia, not route their traffic. I did read something about that as well.
Yeah, which also had some implications, because the way that Russian traffic is routed, you look at the ARN of how DNS is handled and routing is handled to Russia, like, it doesn't make a ton of sense anyway. So,
yeah,
I haven't looked at the BGP table. That's what you'd really want to look at as well, just to see, what the peers are directly to.
Well, that's where you'd go to drop a country off the internet. Is BGP.
Yeah, I mean, you could try. I mean, BGP obviously is ultimately vulnerable anyway, and it just takes one peer somewhere to route the traffic around whatever peer is dropping.
It was made to be resilient as well, as much as we want to say it's not secure, right? But it was made to be resilient
routing protocol.
Yeah.
So yeah, you could say, okay, U.S. and all neighboring countries that are peering with Russia, stop. Well, that doesn't mean that China's not going to peer with Russia and carry the traffic anyway.
Correct.
Right? So it's a lost game unless you balkanize the entire internet, which I've been predicting for many years now, and that day is coming.
Well, the fun one that they did was to hack all the EV charging stations and put, Putin as a dick on there.
Well, I mean, that's part of
that was kind of fun.
That's information warfare right there. Sure. Right. I mean, that's certainly going to be in play. Yeah.
I also like that they did that with the road signs, any of the electronic road signs. They were doing intentional misdirection. They were taking down physical road signs.
And they were replacing them with signs that all read, "Go fuck yourself."
Yeah. It's just fantastic. Stuff like that. You just got to love.
It's pretty crazy
and necessary. I mean, honestly, they've got to do that type of stuff.
Yeah.
Yeah. You wonder. Are they? So the lead, I think, just dropped. But Treasury Department sanctions against Russia. Like, is it going to come to that? And you wonder, like, it's a double-edged sword.
Are we like 90% there already?
Yeah, there's a lot of sanctions going on, but
they have lots of routes for all that stuff.
They do. There's a lot. It's hard these days.
Yeah.
I thought we weren't supposed to talk about politics. Like, that's what we're talking about.
Yeah, well, I mean, it's got a cybersecurity
and
spin.
That's a wrap. No,
well, there's a security spin, but I also found it fascinating that they're essentially running, their local government online still. That they're taking votes electronically online in their parliament, like right now.
Ukraine or Russia?
Ukraine.
Okay. I just want to make sure we're clear.
Ukraine, which I found fascinating. They're not physically all together in the same place. But they're communicating while this is all going on, and essentially running the parliament online, which I found
crazy. Yeah,
really interesting.
Incredibly resilient, actually, to be able to pull that off.
Yeah.
Well, I mean, I think you live with that threat over your head so close for so many years.
You plan.
You plan.
Yeah, you figure that out well in advance.
Alrighty.
Good commercial for desktop practice.
Right. Well, that will conclude this edition of Paul's Security Weekly. Thanks everyone for listening and watching. Larry, take us out.
Over and